First of all, good morning, everybody. I would like to introduce our one of the case studies that uh, we apply it into a real-world scenario. It is based on Mindanao. Together with Sir Dan Santillan, with what we present lately is the in advance is that inline traffic shaper. So let me introduce myself first. So my name is Archelle Louie A, also a network architect. Currently, we are doing a business in General Santos City, which is the Data-Byte Computer Sales and Services. So, which is also a licensed third-party wireless internet service provider, which we cover some portion in Region 12. So basically, currently I have the certification with the Mikrotik and the other brand for the use on our network. So basically, we do wireless internet connectivity with the last mile, especially in Mindanao. There is a very many remote areas that is the major ISP and the Philippines are not able to cover. Then we do manage network services also. Then the wireless iSCADA, which is the disaster monitoring for city surveillance and barangay. Then the quick deploy wireless security system, if there's an event, we do the streaming, and especially if the event is located in the far area and remote area, we do the solution in order to stream the certain functions. Then the wireless hotspot solutions. So on this topic, based on Sir Dan's presentation, we integrate also the inline based on our, but in this presentation, this is our actual real world scenario that we deploy. So I will going to present our long range wireless deployment with a combined case study. Then the wireless Mikrotik. I'm sure here in the Philippines there are limited people who is using Mikrotik as their wireless backbone. Then the same time with the OSPF network via wireless, Mikrotik wireless. Then the full duplex wireless backbone setup by using all also Mikrotik. Oops. Okay. Oops. Wait. Okay, here we go. Oh, okay, as we resume. So this is the, we will also demo the, by using wireless device, we are able to do the 3 by 3 wireless long range point to point. Oops. Wala. Ayan. Okay na. Ayan. So here, so this is our case study. Currently, we have one client which is located 97 kilometers far from the city center. So which is, this is a local government unit that is in need with a stable data connectivity and voice and radio VoIP for their disaster response. So basically, this client is located on a very remote island somewhere in Mindanao. So which is, first they tried several type of solutions, which is the very most common solution is to put satellite connectivity. But since the data they're going to use is, they will use it for disaster response, which is if something disasters happen, with the satellite technology, you are not able to do communication, especially in bad weather. So which is, we find a possible solution, which is the point-to-point. So which is possible, but since the client is located, which is far, very remote island, then which is the problem is it's a overwater link. So what we do is, we will try to make it in an actual real world scenario, which is to deploy an off-grid, which is the power is the number one, also is the issue. So we will put an off-grid point-to-point repeater, which is bundled with the Mikrotik board series, which is, they have the new module, wireless module, which is the 3 by 3 AC series, which is the R11. Then we combine with the multiple high gain point-to-point antenna in order to reach the 97 kilometer point-to-point link. So this is the possible area, the client, which is located in Balut Island. So it is a municipality of Sarangani, Davao Occidental. So this is the remote area. So how we will do the, we will find the good line of sight. So basically we do the path profiling, which is we're able to get a higher elevation as much as possible. So this is our engineering challenge. So number one issue, it will be the line of sight, then the multipath. So what does the line of sight mean for an electromagnetic wavefront? Just an example. If you do the overwater link, especially on the long range scenario, let us example the K1 is equals with a cool and dry situation. This is our typical point-to-point. So the constant density and the height is the same time. Then we should consider the curve of the Earth. Then the K4, if something happened, which is, this is the less dense and more dense, which is common. This is our stable current signal. if there's no thermal inversion happen, thermal duction. But in this is one of the case happen that some of you, if you do the overwater link, especially more than 20 kilometer, as you can see, sometimes in daytime, you are able to get sometimes no signal, sometimes disruptive signal, unstable. Then it will stabilize if it goes in going to midnight. So if the K factor is above 3, which is the refraction and temperature inversion, which is it will, for example, it's a sunny day area. So the typical signal, it should be point to point to the site B. So your signal is going to be up due to the temperature. Then if something happened also, if the weather changes, like there's a rain or something like weather changes during midnight, the K factor will be reduced. Then your signal path will be, instead into the going to the site B, it will reduce. That will cause you an unstable signal. But in real world scenario, this is based on the theory. This is what we encounter most of. So due the path and some, we cannot honestly 100% get the accuracy with the design. So what we do, the solution. This is our solution design. So as you can see, this is our almost 100 kilometer point-to-point link, one hop. Then the area we find for the good point-to-point spot is all above 2,300 feet above sea level. So this is one of our case study during the deployment. So this is on the Balut Island. So it's very remote, actually. Then that's why we put solar in order to power up our gears. So, and this is the summit we're facing to General Santos City. Then on the General Santos City side, we have our Sanchez Peak, which is one of the highest peak located in Jensen. It's about 2,500 feet. Then this is the line of sight going to Balut. So based in theory, if you do the path profiling, as you can see, it's line of sight. But in real world scenario, we don't know if it's going to work. So this is our path profiling. So based with the new Mikrotik wireless series card that able to provide multiple chains output, and with the AC chipset, we have a large probability to get what are going to transfer the bandwidth to the site. So this is our equipment, what we use. So we have the two set of CCR9 on both site 1 and site 2 for the routing. Then two sets of the Mikrotik outdoor enclosure. Then two sets of the Mikrotik 953 with a built-in 5H NT board. But since we are talking about AC series with the new R11, we put two R11 on both sides. So a total of 4. Why? It's because we will separate the bandwidth traffic since the downlink and uplink ratio, which is commonly designed on one radius. So it will operate only half duplex. But with this type of deployment, what we're going to do is we will separate the transmit and receive. So it will provide more flexible. It will not stress out the wireless chip, more latency, much more stable latency. Then with the new R11 series wireless card of the Mikrotik, they are able to do 3x3 output, which is most of the wireless network, wireless module available on the market, they do just only 2x2. So with the 3x3, we have a large capability that, large possibility that we are able to do the point-to-point on this 97 kilometer. If whenever something happened with the weather thermal changes. Then this is our network design. So as you can see, we on both sides, we put 3 antennas on the site A and another 3 antennas on the site B, only for one backbone link. So there are more multiple redundancy. Why? It's because in common wireless situation, we just do horizontal vertical, right? If I'm not wrong, most of you use typical wireless polarization. So what we do on this our case is we do the multiple polarization. So this is what we do. On the transmit side, which is the site A, the radio 1 consists almost 1.5 antenna. So which is the radio 1, which is the 3x3 output. We specify the chain 0 of the wireless radio 1. We put on the antenna 1 with the slant conversion kit. Or any antenna that have slant 45 degrees in order to avoid the thermal invasion and duction. Then the chain 0, the chain 1, we will use the vertical slant 45. Then the chain 2, which is the third output of the radio of the wireless card, we use the typical horizontal. So what we do on the another radio, this is our transmit radio, radio 1. Then our receive radio is radio 2, which is the same. We do the slant horizontal, slant vertical, then the standard horizontal. Or, sorry, the standard vertical. It's because we use the horizontal on the radio 1. Just mistype it. So the same with the site B. So before this, I will going to demo the configuration by using the NV2. We use the NV2 protocol in order to deliver stable and low latency to the site. So the tips before creating wireless, make sure the following situation, all the antenna cables are properly connected before turning on the radio modules. Then do the spectral analysis if there's something interferes with your assigned frequency. Then make sure to comply the regulatory compliance based on our country restrictions. Then make sure that all radios are properly grounded. So this is what we do. We configure on the site 1 both access point. Oh, both access point. But you said is we do receive and transmit. But we do this access point. As you can see, I'm not sure if you, it's very blurry actually. I have here, we configure the wireless mode into AP. Here, we configure the AP, then configure the frequency. Here is a AP bridge. Then the 5 gigahertz. Then specified with the channel width based on your requirements. Then the important is we do the NV2 protocol. So at the same time, we should enable the 3x3 MIMO, which is you're able to use the 3 output of the wireless. It's because sometimes in default settings with the Mikrotik, they just utilize 2x2. Then the AMPDU priorities based on your scenario. So then the advantage with the Mikrotik, you can configure Mcs Rates based on your requirements. So unlike with the other device, you can specify only ranges. But in Mikrotik, you can specify individually, which is much more flexible for me. Then the NV2 protocol. Then by the way, some of you tell me, does the Mikrotik have GPS synchronization? Someone? Someone can tell me. Does the Mikrotik have a GPS synchronization under all AP? So I think it's a no, right? There's no GPS. But here on our setup, since we are using multiple radio, multiple modules on per site, which is you're going to encounter sa interference, if not synchronized, right? But in this case, we are able to do the GPS synchronization, but not the typical GPS side that we put there's a physical GPS antenna on their module. No, it's not. There is another way of approach Mikrotik did before that GPS technology is developed, which is the Mikrotik use Ntp Time Synchronization on all radios to synchronize the time and timings on all wireless. So that's why we are able to do the Tdma. So we can also do the dynamic downlink ratio, which is commonly, as you can see, we can penalize the download versus the upload instead of the equal. So in this case, we do the dynamic downlink ratio. So which is the Tdma period size, which is, it depends also the how many ms, which is the time frame. Like if some of you encounter with the GPS synchronization, if you do the Tdma policy, which is you will penalize the download versus the upload, you need to specify the Tdma period size, which is commonly starting from 5 ms, 6, 7, 8, and so on. So in this case, on our 97 kilometer link, we do the 8 ms Tdma. Then the cell radius, which is we specified 100 kilometers for this link. Then the NV2 security. Then on the site 2, we do the wireless configuration in order to connect to the site 1. So it's just typical point-to-point. Then luckily, we are able to get a negative 63 signal on both sides, which is sometimes if there's a scenario like very sunny, sometimes it's very rainy, yes, it's normal, the signal will degrade. But due to the 3x3 MIMO, you are able to get the backup and an additional link in order to get the Mcs rate you desired. That's why we are able to get, so far for the 7 days uptime, we are able to get stable 100 Mbps plus for this link. 100 Mbps for the downlink and 100 Mbps for the uplink. Then sometimes in good situation, we are able to do 200 megs downlink and 200 plus megs in uplink. Depends on the situation. So at least we are able to do stable 100. So this is the configuration with the station mode, commonly. Then for the routing configuration, why? Let's assure on both site A and site B, we do the routing. We're not doing the typical bridging scenario. So let's assure on this case, I will going to have a live demo on the network. We will do the speed test also, and I will let you show the wireless interface where the traffic goes. And since on my case, we do the failover also. If something, the radio 1 broke, or either there's a physical damage, by utilizing even the one radio, they're still able to communicate. So let's consider like this. We already configured the OSPF on this network. Then it's already established the wireless link. Then it have an MPLS network. So tips, just like what I've said before, there are 2 types of common setup that we normally use, which is the typical setup is the bridging, which is common obvious. We do the VLAN, bridging VLAN in order to communicate to site. But on our setup, we do the routing. As you can see, the advantage with the bridging, it's very easy to set up actually. But the disadvantage side is the broadcast traffic. Whenever the more clients you have, the more broadcast traffic you have with the bridging. Then it's prone into the local loop and something happened with the typical physical connection, it will break down your whole network in just one blink of an eye. So that's the disadvantage with the bridging. But in routing, the advantage with the routing is there's no broadcast traffic at all. Then at the same time, if you do the bridging, it will use the CPU of the Mikrotik also. With the routing, it's just pure IP to IP. So it's much more flexible, then much more easy to process due to the IP to IP communication. But the disadvantage is more configuration, multiple IP networks, then use of the routing protocols like OSPF. So let me show you our live demo. So here's our live demo. So currently, I'm connecting to our main server here. Here is our main server, as you can see. In this situation, I'm connecting from the router 1, which is on our side, on our main server side. So the IP address of the remote side, which is, let me show you this, is our, in order you to, here, we are accessing the router on this side. Sorry, this side, on the client side, client router. So what we do the speed test going to the site B client router side. So in this case, the client router side is the 170.6. So we do the bandwidth testing. So before that, let me show you the, this is our wireless on our remote side. As you can see, this is on the site 1. This is the current registration of the wireless. As you can see, there's no firewall rules, NAT, Mangle, any. And also bridge. I just use bridge for management purposes. But on bridging on both our traffic, we do pure routing. As you can see here, we do the IP addressing. Yes, here, yeah. Then the IP routes here. So as you can see also on our wireless network, we do not use the OSPF also. It's just all pure static routing. So the main routing configuration is done by the, here, our PE router. So the wireless radio just act as just a pure layer 2 traffic in order to establish a stable connectivity to the going to the site B. Okay, so right here, as you can see, since what we do on wireless radio 1, we do the transmit, and wireless radio 2 do the receive. So let's us try speed test going to. So for this case, we'll just use the receive first from the site B. Then we will just limit it into 200 megs. Let's try. So this is our currently 200 Mbps. The latency going to the site B so far, 5 ms, 15, 14, I think less than 50 ms. By consuming 200 Mbps on 100 kilometer link. Then to see the actual with access the wireless, here is our wireless. Yeah, there you go. The radio 1 acts as a receive. As you can see, there's no transmit or receive on the radio 2. But if we do the bandwidth test on both sides, As you can see, we'll do the speed test here. Both able to do 200 megs. And the wireless radio on both sides here. 200, 200. 200 on the receive, 200 on the transmit. So in this case, we already implemented the full duplex. Then we have this here, the wireless registration. It gets actually, for now, we are able to get negative 57, negative 68 on both chain. Actually, we are able to get signal on both chains. Where I can get that. My screen will not fit. Here. Let's try. No. Eto here. RX signal chain on RX0, RX signal chain on RX1, RX0 chain on RX2. There. That as you can see, RX signal chain 0, we're able to get negative 75, 77 negotiation on wireless 1, then negative 54, 64. It's very random. But due to the triple processing power of the R11 radio, it maintains the Mcs rates. That's why we are able to get higher bandwidth. But in 2x2 chain, if one chain is going to scrambled or missing, all your links are going down. But with this multiple diversity, you are able to get the much as better signal compared with the 2x2. So right here, this is our bandwidth test. But due to the limitation of the CPU also of the RB951, as you can see, the processing power, it will not fit. Here. Processing power CPU, it ranges about 80% already. But still, 200 Mbps at 100 kilometer is a very big bandwidth actually. For this is for the exclusive for our local LGU client. So in this case, so this is how our multiple diversity and full duplex, just like with other brands, the separate radio for the transmit, separate radio for the receive. So in this case, what we discuss next is the failover. What if on site 1 or site B, one physical radio is broken or have a physical defect? So let's try here, for example. As you can see, with the let's do the example. Let's disable the wireless LAN 1 to simulate if there's a signal inversion or there's a factory defect with the device or any physical damage. So let us disable. So the registration is not. So as you can see, we will going back to the speed test. Yeah. Self-healing. So currently, it negotiate with the receive, but transmit still left 0. Then our ping, yeah, timeout. But let's just wait a little bit for the self-healing to come. So due to the routing policy on what we have programmed, it just take only several seconds in order to self-heal the entire network. It's because it will calculate the path again and the cost on each network, right? Here, there you go. Yep. So this is our wireless. Let's check. Yeah, there you go. It receive 200 megs, then transmit. Let's wait a little. Where's the latency? It will calculate the path again. There you go. Yep. The advantage with the Mikrotik, by the way, in other brands, most of common, if you do the Tdma, you need to specify traffic ratio 67/33, right? Fix downlink ratio. But in Mikrotik, you are able to do the dynamic downlink ratio. You can specify the priority. If you put a downlink ratio, like okay, I will make 70% download, 30% upload. That's the current setup. But the power of the Mikrotik operating system, it enables to analyze the real-time traffic. If it use the uplink ratio more than the set bandwidth limitation, it will automatically split into a 50-50. So as I can see here, on our network, let me try. Oops, got disconnected. So currently we're able to do this. Oh, why is that coming? Yeah, there you go. Why is still not coming? Let's start. There you go. So the transmit and receive ratio will change differently. Oh, wait. Let us check. 200 Mbps on the downlink session. Transmit ratio, it gets 50 Mbps. Wait, let's stop. Let me resume first. Where there's a traffic passing by. It seems there's something wrong with my Winbox. Let me log in again. There's a passing data. Wait, let me resume. Let's check if it will resume the connectivity. So, wait. 137.1. Oops. There you go. We will try the speed test again. So here, our current wireless radio. Wait, still. Wait, let me check. I actually messed with the configuration link. Sorry. Here we go. Okay. So let us wait to get back our connection. What happened? Wait. Let me reboot. There's something wrong. Anyways, the one of the most advantage on our network design is we use the both horizontal vertical with the slant. We'll just wait with the router to restart again. I think I missed something on the settings. Oops, wait. Here. Wait a minute. Site 1 RB. Okay, there we go. The 3. Oh. There you go. What happened? System CE router 1. Site 1 routing core. It seems there's something I missed with the configuration since I changed something lately. So it does not come back. Sorry. Wait. So anyways, wait, let me check again. Site number 2 routing RB core. I'll just reboot the router site. Yeah, it's okay now. Yeah, I found the root cause. I just reboot. Okay. Yeah, yeah, there you go. Oops. There. We'll just wait another 20 seconds to resume. Okay, wait. Site 1 router, okay. Yeah. Okay. Anyways, just fix and it seems I've messed one of my configs together with the yeah. There's something wrong with my configuration. But actually, we already observed it for almost 7 days. So far, we are able to do the almost 90% uptime together by using this wireless with the R11. So anyways, that's all. Any more question? Yeah.
Yeah, thank you. Any questions?
You can ask if you have any confusion with the concept. Feel free to ask. Anyone? Anyone? It seems it's all good. All right.
Thank you. Next one presenting will be Ahmad from GLC Networks.
Okay, great. Test one. Okay. Good morning. Doesn't sound good? Morning. Okay, that much better. Thank you. Okay, so today